So in the last class, we discussed about OSL layers and we completed OSL layers. So then we can go and we can discuss about little bit in-depth analysis of the couple of other protocols as well, a part of the OSL layers and also TCP IP layers.
So first one is, by the way, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Sir.
perfect. So first one is router and the second one is switch. So we can discuss about differences between these two. And once this one will complete, I will go to some other topic. So already we discussed about these two. So router will fall under the layer number 3. That is nothing but network layer 3. That is also called as the layer 3 or else network layer as per OSI. And a switch will fall under the data link layer. That is also called as the data link layer as per the OSI reference model. So that is the first one. So router will fall under layer number 3 or, so what is the another name for layer number 3? Network layer. In the similar way, switch will fall under layer number 2. That is also called as data link layer. So that is the first difference. What is the second difference? Already we discussed all these things. Just I want to make it like one of the difference. What is second point? Any idea?
Internet.
We talk about the VPN.
Logical and physical address.
Unfortunately, your
access
voice is
internet.
chopping.
It is an intelligent device.
Okay.
Which is intelligent.
It is an intelligent device. And also switch also.
Providing
Internet. We use internet for router.
Vamshi, your background is too much noise. Yeah. Router will use
Internet.
data format as IP packets, and switch will use
Frames.
data format as frames. So that is the second point. And router will support for internet. Whether switch will provide internet?
No.
Yeah,
no.
switch will not support internet connectivity. Next one, router will support VPN, but switch will not support VPN. Next point is router will use data format as IP packets. What about switch?
I think it's already written in second point.
It's a data frame. Switch will use data format as.
It's already written in second point. Already you mentioned that point.
Okay, sorry guys. Sorry, yeah, it is written already. Yeah, sorry. Next one is
Both are intelligent devices.
Yeah, router is an intelligent device and switch also as an intelligent device. So next point is what is meant by intelligent device. I'll explain. Maybe for example, consider as, so right now maybe around 45 members are joined in this call. Whenever I will make an announcement stating that, so Akhil, did you join the call or not? He will respond back whether he joined or not. In the similar way, Ashok, whether he joined in the call or not, he will respond back. After that, Vamshi, if I will ask whether he joined in this call or not, he will respond back. Now I can go and I can verify whether Akhil or Ashok or Vamshi is a part of this particular routing or not, and they will accept broadcasting of the traffic or not. So it is almost, it's equivalent to our registration part, our, or otherwise we can say like our absent or leave. Whenever we are making any, so who is absent and who is present in the class, I can pinpoint as according to the respect to roll number or according to the respect to name. And whenever it is matching to the roll number or name, they will respond back. Now, as a instructor or as a teacher, so then I can go and I can re-verify whether appropriate person is responding back or not. I will re-verify that information, and finally I will say whether the candidate is absent or present. So that is the way how I can make sure that as an instructor, whether the respective candidate is absent or present. So how I am making sure that based on the respective candidate, yeah, respective candidate roll number, name, and also acknowledgement. Same way, switch also can make sure that, so whether whenever someone is responding back, what is the IP address, what is the MAC address, and also what is the, so device is responding back, whether all those parameters will validate. So once those parameters it will validate and correct person is responding back, then only it will give the so respective so response back. So that is the reason always router and switch we can consider as a so intelligent device. Okay. In the similar way, switch also has an intelligent device, but hub is not an intelligent device. So whenever someone is responding back, hub will not recommend that, or hub will not respond back who is responding back. That intelligence doesn't have the hub side, but switch and router can do that. That is the reason switch is an intelligent device and also router is an intelligent device, but hub is not an intelligent device. Hope it's clear. Any
Yes.
doubt in this one? Any doubt? Okay. So now I'm keeping here 6th point as I will ask all this question at the time of the ARP poisoning attack, DNS poisoning attack, or DNS spoofing attack. Router is an intelligent device and also switch is an intelligent device.
Sir, already 5th point is.
Yes, sorry guys. Yeah, at that one in-depth analysis I provided part of the 5th point. Router is an intelligent device and switch also is intelligent device, but hub is not an intelligent device. Whenever any packet is responding back. Router and switch both, it will respond back. It is traversing in between source and destination. So next one. So router is over.
Router will have
support
the
the router will
IP,
provide
IP
VPN.
address.
Yeah. Is there any other differences?
Router will have the IP address, but switch will have
Router will
MAC
use
address.
logical. Router will use logical address is called as IP address. Switch will use physical address is called as MAC address. So these are the main differences, guys, in between router and switch. I am repeating once again. A router and switch will support both for broadcasting of the traffic, and also router is an intelligent device and switch also is an intelligent device. Router will use data format is a IP packets. Switch it will use data format as a frames. Router will fall under the layer number 3. That is nothing but network layer. Switch will fall under the data link layer. That is also called as the data link layer. And also router will use logical address. That is called as IP address or numerical number or label assigned to each and every system connected in the computer network. And switch will use physical address. That is called as a MAC address. It is a unique address, not unique address. It is an address basically based on the Ethernet interface is configured on each and every system. Every Ethernet interface has NIC card. Every NIC card has a physical address that is called as a MAC address. So these are all the difference between router and switch. And if you want to connect two buildings or two cities or two areas or two countries and two continents, router is a mandatory device, but switch will not support. So those are all the main differences between router and switch. Router, indirectly, we can call it as a NAT mode or layer 3 mode. I'll keep one more difference. Routing using router is called as layer 3 mode or NAT mode. So whenever firewall, if you want to deploy in our organization, we can use NATing to convert private IP address range to public IP address range. That process we can call it as the NATing. That process can be defined using layer 3 mode because router will fall under the layer 3. That is also called as the NAT mode. So in this similar way, firewall also can be deployed using switch mode. Switch using or switching can be used. Switch is called as switch mode or layer 2 mode. So switching of the respective switch also called as switch mode or layer 2 mode. So firewall can be deployed either layer 3 mode or layer 2 mode. Not only these two modes, even we can deploy some of the other modes like tap mode, high availability mode, and also we will use like a passive mode or transparent or virtual mode. So these are all the ways we can define. So firewall as a layer 2 or else switch mode or layer 3 or else so root mode, transparent or else virtual or tap mode or high availability mode. Which one is better as per your opinion out of all these modes? Which one is better?
Outer.
NAT mode.
Outer.
NAT mode or else root mode? Why NAT mode or root mode is better other
Public
than
IP.
NAT mode? No, it's not about public IP.
IP
Sorry.
mask.
No. Because every organization nowadays without internet they can't do business. If the
Internet
internet
based.
wants to, yeah, if the internet wants to run, obviously router is a mandatory device. Switch can't do that. So that is the reason always. So root mode or layer 3 mode or NAT mode is a mandatory to get the business or to get the profits or to get the losses as well. So according to our business requirement, we can go on. So we can make always NAT mode or layer 3 mode or internet facing mode or else root mode. Okay. Okay. So this is the way how we can deploy the firewall that we can discuss in future. So let's start some other topic, part of the our voice layers. So next topic is the TCP flags. So already we discussed about around 3 flags, part of the TCP whenever connection is established or connection is closed in between source and destination. Those 3 flags are, one is sync or synchronization. Second one is FIN or finish. Third one is ACK. And fourth one is URG, that is also called urgent. Fifth one is push PSH. And finally reset RST. So these are all the ways we can configure the TCP flags whenever any packet is traversing between source and destination. So these flags are so well-known flags whenever any packet is traversing in between source and destination. Okay. Now we can go on, we can discuss about each and every flag importance, why we can use these flags and what is the importance. Let's start now. First one. So SYN, that is also called as synchronization. Where we have used this synchronization flag, part of our voice layer approach. Flag is nothing but like identity basically. So I want to clarify, someone is raised. So Pawan, yeah, Pawan, basically to you, it's like a flag is nothing but tagging part. Okay, so something if you want to tag, we can use flag, not like our Indian based flag or American based flag and so on. So it's like for identification purpose, we can use flag. So now coming back to here, synchronization flag, why we can use in between source and destination. You're welcome. So whenever if you want to initiate a connection establishment purpose, we can use synchronization flag. Nothing but it's the initial connection in between source and destination. We can use synchronization flag. So, and also I want to clarify one more thing. Whenever if you want to enable flag or disable flag, there are two different types of approaches here. Enable, we can call it as a equals to 1. Disable, we can call it as equals to 0. So we have done couple of engineering labs, part of the our electronics and devices circuits, part of the engineering, and also part of the STLD life cycle and programmable logical array and so on, even along with electrical as well. Enable, so we can call it as a 1, or disable, we can call it as a 0. So that is the way how we can define the Boolean algebra function. So here, whenever any synchronization flag is enabled, nothing but equals to 1. whenever any sync flag is enabled, what is the true condition I said? Equals to 1 as a true condition in between source and destination packet or connection is initiated. So that is called synchronization. So for connection initiation, we can use synchronization. So that is the first one. What is the keyword we have to remember? Connection initiation between source and destination. Second one is ACK. What is the ACK full form? Acknowledgement. So acknowledgement is nothing but it's a feedback or survey. So whenever any packet is traversing in between client and server or peer-to-peer or source and destination, so respective peer device will respond back. I received the packet. So that is called as acknowledgement or feedback or survey. Whenever ACK flag is enabled, in between source and destination, feedback or acknowledgement is received from other peer device. So that is called as acknowledgement. Third one, we can call it as FIN, finish, full form. So when we can use this finish flag, part of our TCP IP packet or IP packet. So this packet is a lost packet. There are no other packets are sent in between source and destination. So those cases we can use finish flag. If FIN is enabled, there is no other packet can be sent in between source and destination, or else peer to peer. So that is called finish. Next one is RST. So RST full form is reset. So why we can use this reset flag? If we want to make a connection freshly, whenever any internet issues will occur, or whenever any connection wants to make sure that newly it has to form. For those scenarios, we can use reset flag. For example, you are watching one of the YouTube video, maybe Bahubali movie in the YouTube, and suddenly your mobile data got so expired. What you have to do now? You have to recharge once again. And so whatever connection you are taking, that may be Airtel or BSNL or Jio or Vodafone and so on, you will recharge. Now wherever the connection is stopped or interrupted, from there it will make it like a fresh connection, and you have to refresh the respective web browser, part of the YouTube. From there, connection will be established once again as a newly or freshly. Then you can watch Bahubali movie once again. So that is one of the practical scenario. Second scenario is a part of the practical or day-to-day life. Resetting of your mobile. What is meant by resetting of your mobile? Whenever you are purchasing your mobile or maybe your tab or maybe your laptop, if you are making factory resetting option, so factory resetting option, what exactly it will do? It will erase existing data, whatever you have already configured or whatever you are saved or whatever is stored. Everything it will erase, and finally it will make like a new fresh So laptop or MacBook or fresh mobile or maybe tablet. So that entire erasing of the data as a fresh connection or fresh piece or fresh mobile or fresh laptop or MacBook is called as a reset. It's called as a factory reset. Same way, whenever any packet is dropping and packet is retransmitted, is a freshly that what is meant by that particular so fresh meeting of the respective connection is established is called as newly connection is established in between source and destination as a new connection. So that is called reset. So whenever any RST flag is enabled, in between source and destination, connection will form freshly or newly without considering existing data is called as reset. So that is about fourth point. Next one is push. So this one already we discussed, part of our TCP layers or OS layers. Whenever we are assigning push flag, so as we discussed part of the transport layer, as I said, so one of the sentence I formed, RK, is there any class today or not? What transport layer it will do? It will provide segmentation, it will provide data flow control, and also it will provide error-free control. That's what we discussed. Hope did you remember? Did you remember, by the way?
Yes.
Yes,
Yeah.
sir.
So what is the example I given? RK, is there any class today or not? So now each and every segmentation, whatever it is making part of the larger chunks of the data is converting into smaller chunks of the data. Every segment has a segment ID, acknowledgement number. In the similar way, source port and destination port. Whenever push flag is enabled, so in between source and destination are peer-to-peer devices. So whenever the packet is traversing, so always it will keep everything in like in a buffer. So that buffer we can call it as a temporary cache or cache. Now, in case large flooding of the request sender is sending, everything it will keep in the buffer or temporary storage according to the priority of the respective packet. It can be give the segment ID and also it can give the respective so sequence number, acknowledgement number, so source point or destination port and so on. So even though we are assigning the respective push flag, it will follow the sequence. So even though in front of the so push flag it is enabled, is there any other existing packets are there? It will follow the sequence. It will not follow so unnecessarily whatever packet is highly prioritized. It will follow that particular sequence is called as push. So that is about push. Then I will take one more example, urgent, URG. Same thing. So RK, is there any class is there today or not? So that is one of the example I given. Maybe RK, it's a part of the urgent priority, number one priority. So there is a second priority, not is a third priority. So in such a way, if you are giving the priority wise, now RK and also is or not, there or not, and so on. So wherever you are enabling the urgent priority, those flags it will make it like a first priority. And after that, whatever we are giving the temporary cache or maybe cache, so that one it will make it like a so other priority levels. Now finally, if we are making that one is high priority, so it will not follow the proper sequence. It will not follow the queue. So that is called urgent priority. So once you are making urgent priority, whether recipient will receive the proper way of the sequence, most of the cases it will come lot of errors. So that is called urgent priority. But always urgent priority, we can make sure that is there any existing packets are there in front of the queue or not, part of the so stack or maybe peer-to-peer device, and whether meaningful message or sentence can be received by recipient or not. For those scenarios, we can assign the urgent priority. So that is the difference between push versus urgent. Which one is very benefit for us? Urgent or push? Urgent is better or push is better?
Push is better.
Exactly, push is better. Push is better because we are not giving any priority here. We'll make sure that whatever or whoever is there in front of the our queue, we can push them. Okay, please quickly you can complete your work. We are not making so someone is priority other than other people are not priority. Everyone is equal, whether he is a rich or whether he is a poor. Okay, there is no recommendations here. So that is the reason push is always better. Okay. So that is the way how we can differentiate push versus urgent. So whenever push flag is enabled, in between source and destination, always it will follow the sequence or queue, but it will push existing sequence of the packets as an order. That is called push. Next one is URG. That is called urgent. So why will this give the urgent priority? Whenever URG flag is enabled, in between source and destination, that packet will give high priority to traverse in between source and destination. So that is about urgent. But it will not follow any sequence. But it will not follow any sequence. So that's what I give in practical example as well. Whenever some person met an accident or that particular patient is in critical condition, he will not follow any token system in the hospital. Emergency ward or emergency condition, so those people give high priority part of the money collection from the hospital side to make sure that patient should not be dead and he should be alive. So same way, so here urgent flag is enabled, that particular packet has to give high priority even though existing packets are there part of the cache or temporary storage or else buffer. So these are all the different types of flags we can use in between source and destination whenever any packet is traversing in between peer-to-peer or else source to destination. By the by, we will not allow as a human being which packet has give to high priority and which packet is give to low priority. It's completely based on the what is the existing content it is traversing or data or packet it is traversing and who is there part of the temporary cache or buffer. And according to that one, as part of the transport layer, it can make sure that so which packet has to give high priority and which packet has to give low priority. So completely it's an automatic system. There is no need to give any manual way of the verification. The packet is traversing in between source and destination. If I can ask, did you give any priority whenever something you are searching in the Google, or maybe withdrawing some of the money from the ATM machine, or maybe you are transferring the money from the PhonePe or Google Pay, are doing everything as a part of the TCP flags are enabled, part of the transport layer? Are doing from manually?
No, we are not doing manually.
Exactly, that's correct. It's everything is a back-end system and back-end configuration. From front end, we can't see this one. All these are most of the case it's a back-end process. Okay. So that is about TCP flags. Let's go and start about transport layer. Sorry, TCP IP layers. Apologies. TCP IP layers.
RK.
Yeah, please.
So basically, sync is the first step which we are doing in a three-way handshake, and your finish would be the last one, right? So basically, when we are doing this three-way handshake or connection establishment, sync will be requested from the client side or the user, right?
Yes.
And finish will be sent as a response
from the
server side. So these actions will
Yes,
be performed by client and server.
Yes, correct.
Okay, fine.
Yeah, that's correct. Whatever you said, absolutely right.
No, basically, when you have written, I've got confused at the starting initial stage.
Okay.
On the top.
Is
It is in between. It said it was like it is enabled in between them. So I was like asking, is what my understanding is correct or not?
No, your understanding is correct.
Okay, thank you.
You're welcome. So now I'm making TCP IP layers. TCP IP layers like advanced version of the voice IP layers. And also, please remember one thing here I want to clarify. Voice layers is also called as a voice reference model, and the TCP IP layers also called as TCP IP reference model. Reference or layers are both are same only. Don't get confusion here. Nowadays we are using whenever troubleshooting purpose or packet capture analysis, we are not using any more voice layers. Completely, we are using TCP IP layers. For example, you are implementing EDR tool. EDR is nothing but, what is meant by EDR?
Endpoint detection.
Response.
Endpoint detection response. It will prevent and block all malware category of the attacks. That may be virus or worm or Trojan or ransomware attack or botnet or logic bomb, adware, spyware, potentially unwanted program, PowerShell execution, Python execution, and so on, or lolbeans and so on. So that is mean by our malware category of the attacks. Now, whenever if you want to troubleshoot whether the EDR agent, what is mean by EDR agent or antivirus agent or DLP agent or HDS, HAPS agent or is file integrity monitoring agent or proxy agent? Agent is nothing but a piece of software program code that can be deployed in our organization side. I have shown already in my personal computer McAfee agent. In the similar way, in my professional organization also, we are using one of the agent name is called as Windows Security, and also we are using Falcon Sensor agent. Recently, whatever Microsoft system is got compromised, It's a global impact. Okay. So now coming back to here. So whenever if you want to troubleshoot in between source and destination, always we will not go with voice layer reference model. Always we'll go with TCP IP reference model analysis or TCP IP layer analysis. How many layers are there part of the TCP? There are 4 layers.
4 layers.
4 layers.
Application, transport, network or internet, network interface. So these layer approach we will follow. It is one of the very, very favorite interview question if you are going for especially endpoint security, Wireshark analysis, and also how can you troubleshoot packet capture analysis. Couple of companies example I will give. IBM Kyndryl, PwC, part of the EDR agent, Google endpoint security vacancies. We have seen always whenever those companies they are recruiting endpoint security vacancies, and if you want troubleshoot EDR or antivirus agent or DLP agent or encryption agent or proxy agent or file integrity monitoring agent, always agent plus based approach. We can go and we can troubleshoot. Not only that one. Second scenario, cybersecurity SOC operation. Whenever if you are onboarding any log source logs to SIM tool, in case logs are not reflecting part of the raw log versus parser log, we can do the packet capture analysis. That is second scenario. Third scenario, if you want to integrate any server logs or Windows logs or endpoint logs to SIM tool, logs are not reflecting using collect agent method or win collect agent method, where, when, how, why logs are not reflecting. We have to take care of the TCP dump file, or else also we can take the packet capture analysis in between source and destination. Finally, we can make sure that, so where is the issue? Whether it is the issue is there in between application site or transport site or internet layer or network layer site or else network interface layer site. For those scenarios, we can use TCP IP layer analysis. It's a complete implementation. For example, today in my organization, couple of people are deploying IBM QRadar 7.5 SIM tool. So if they want to, obviously, whenever we are deploying SIM tool, we got lot of troubleshooting issues related to source and destination, where we are deploying our IBM QRadar versus where we are configuring from our end user laptop. Now what we have done, in between IBM QRadar where the SIM tool is deployed in the virtual machine versus where we are configuring everything from our laptop. We have done the packet capture analysis and we have troubleshooted. Finally, we found whether the issue was there part of the application or transport part of the TCP three-way handshake in between IBM QRadar versus my laptop or workstation or desktop. In the similar way, whether any packet is retransmitted or packet is dropped or packet is allowed in between my laptop versus IBM QRadar tool. Finally, is there any network Ethernet interface related issues like a bridge network or root network or NAT network? All those things we have completed through network traffic analyzer or network traffic analysis using Wireshark and also using Microsoft Network Analyzer. It's a completely implementation level. Is it clear? Is it clear?
Yes.
I don't think so. I can prove it when the practical scenario it will happen, whenever if you want to troubleshoot something. So not only for single scenario, I given here approximate 3 to 4 examples. Part of the endpoint security, part of the network security, part of the cyber security as well. For those scenarios, we can make sure that packet capture analysis can be done part of our Wireshark and also Microsoft Network Traffic Analyzer. It's one of the very, very famous interview question. Do you have any experience on Wireshark? How can you do analysis? Do you have any experience on the Network Traffic Analyzer? Which cases can you make sure that network traffic analysis can be done? Is it clear?
Yes.
Okay, guys. Sorry, guys. I have already one of the meeting is started at 8 p.m. First of all, apologies. I have a lot of issues were there, part of the network. Unfortunately, I did not take 1 hour. Completely from bottom of my heart, I'm giving the apologies. It will not repeat once again. And so I can take tomorrow class around 7 p.m. IST. And good night and sweet dreams.
Thank you. Thank you, sir.
Okay, guys. Thank you so much.
Yes, sir.